So welcome back, everyone. Today we'll be mostly talking about storytelling, but we will also wrap up the network lecture. Can everybody hear me and see my screen okay?
Mm-hmm. Yep.
Yep.
This is working. Can somebody just tell me that they're hearing me?
Yep, we can hear you.
Yeah.
Okay. Thanks. Perfect. Great. So as you recall, like last week, this time we talked about networks, and then we had a guest lecture by Caroline and Nobre about multivariate networks. And when we talked about networks, we talked about explicit node link diagrams, and then I mentioned that there's also adjacency matrices. I think that she covered adjacency matrices in sufficient detail, so I'm not going to go over this in the interest of time, but I put up the slides, so if you want to review the stuff on adjacency matrices from my slides, you're more than welcome to in the slides. But Carolina didn't talk about trees, and so let's start off with how do we visualize trees. So this is an exercise, but I think we are kind of like, we want to spend some time on storytelling today, so I'm going to not do it, but I'm just still going to outline this and maybe have a brief discussion about how you could do this. Let's have this file directory structure from my data visualization lecture folder on my hard drive. I might have like the root folder, then I have 3 subfolders, and these subfolders have more subfolders or files. And now, if I wanted to visualize a data set like this, with like especially focusing on the file size, there's a couple of things that I can do. So first, I could do like visualize what's called a tree map. And we'll talk about that. Or I could use like a node link diagram and visualize these attributes, for example, as bar charts, or similar to like the labels that I'm showing here. So the idea is like trees are kind of like a special kind of visualization, but are a special kind of graph with like some dedicated visualization techniques that work well. But of course, regular tree, like regular node link layouts work just as well for tree visualization. And so here is an example that uses this Rheingold-Tilford layout, either in a radial setup or in like a linear setup. And like if you compare the linear versus the radial, we can see that the linear is a little bit easier to read because all of the labels are like properly oriented, whereas the radial actually fits on the screen here, so it's a little bit more space efficient. So depending on what your context is, if you want people to actually read this in detail, then you might pick one or the other. Of course, trees can be like nicely manipulated. So you can kind of like, if you ever use the file browser, which everybody definitely has, on your operating system, you can kind of like expand subfolders dynamically, and the subfolders kind of like represent everything that's contained within them. And so that's always very nice in trees. And so this kind of like interactive tree manipulation goes back a long time. This is also like this video that I showed in one of the first lectures about interaction by Douglas Engelbart, this mother of all demos, already contained a demonstration of navigating a tree like this. You can also, like, if you have to deal with very, very large trees, let's start with this one. So here's an example of a collapsible tree being visualized. So here I can kind of like click any of those, and then I aggregate them, and I can dynamically expand them in this Rheingold-Tilford layout. So yeah, that's not particularly surprising. That's fairly easy to do. One thing that you can also do is if you have to compare a lot of trees, then there are special techniques to visualize that. And so I'll show like a brief section from this video here.
are often faced with the task of comparing many similar phylogenies, that is, manipulation is leading biologists toward the creation of much larger trees, thousands of species today, and millions within the coming few years. We present Tree Juxtaposer, a new tree visualization tool supporting scalable comparison and navigation of phylogenetic trees of over 300,000 nodes. Small trees are hard to compare with visual attention alone. Linked highlighting of nodes and subtrees helps. Perfect matches for named...
I think the video audio synchronization here is off. But essentially here, this is the idea that you have those two trees that have the same leaves but different structure. And you can kind of like select any of those nodes, see where it is, but you can also select any of the backbone structure. And it has this kind of like nice degree of interest feature, this kind of like fisheye-based degree of interest feature, which we can see here. Like it's not all that, this is like before we had good screen capturing. So this is actually probably filmed with a camera. But you can see that there's like a nice scaling and rendering algorithm in there. Okay, the most interesting piece of was the tree sketch a participant. No, that was like we actually didn't go through that. We'll do one activity at the end of today's lecture. Okay, so the most interesting thing about trees, what's special about trees is our implicit layouts. And so there's three types of implicit layouts. There's tree maps, sunburst, and icicle plots. And what's the idea of like it, as it says, it kind of like has and it is contain or it encodes the edges implicitly. So if you look at the chart that you have down here, oops. If you look at this here, like this tree here, you see that the edges are explicitly encoded. And here, this is the same layout. Here, the edges are implicitly encoded. So the idea is that you like have the surrounding, like the white ball or the white node here is kind of like the whole rectangle. And the whole rectangle is made up of these four sub-rectangles, the blue, the green, the yellow, and the red. Okay, and so you can see that the green and the yellow here are not subdivided further, but the blue one is subdivided further. It has like 4 children, which we can see here. And then one of them in the top left here has 4 more children. And so by doing that, we kind of like get this implicit topology that we encode in this tree map. And so what's super nice about this is that we can now scale the cells or the rectangles by the size or by some kind of attribute like the file size, for example. And so the original tree map algorithm by Ben Schneiderman from 1991 kind of tended to produce these kind of like very thin slices that are not particularly pretty. And so instead, like the Van Wijk's team, Jaak van Wijk's team has developed this squarified tree map approach. And so here, really, the idea is that you kind of like do a horizontal subdivision to optimize an aspect ratio, and then adding rectangles that improve aspect ratio. So if you think about this, if like let me annotate a little bit here. So we start off, we add one rectangle. As we add a second rectangle, we kind of like add it on top of that. When we add a third rectangle, we kind of calculate the ratio, and we can find out that this is actually not a good aspect ratio anymore. And so instead, we kind of like add this rectangle down here, and then we keep doing that. And every time we add something, we evaluate the aspect ratio, and then we backtrack and add it in another way. And so that kind of results in these like nice squarified tree maps. And so here's a comparison of like the original on the left or in the middle, and then the squarified tree map on the right. And obviously, the version on the right is much more readable. One thing that is kind of like a little bit of a problem sometimes if you look at something like this, it's really hard to see how deep a tree gets. So you don't really see the big backbones because this is kind of like the axis. It's just looking for the golden ratio. It's looking for kind of like a good ratio between the two sides. Yes. So one problem that you have with tree maps is that you kind of like, because these edges are implicit, they kind of like are hidden. And so one way of dealing with that is to use this kind of framing. Of course, this kind of gets a little bit tricky because the frames also need space, and so it's not completely, it's not all that easy anymore to do that nicely. And the frames, like for some cases, they might be helpful. For some cases, or for many cases, they are probably not all that useful. And you might have used this kind of software before, like I often do when I like have to identify what's going on my hard drive, what are the files that are kind of like clogging up all my hard drive space. You can use this on Mac. There's like a grand perspective is the name of the tool that you can use to look through your files. And then on Windows, there's Sequoia View, which is actually like sort of open source software that's written by the people who invented the squarified tree map. And so both of them are kind of like super useful tools if you ever need to clean up your hard drive and identify where can I make the biggest difference. Very similar to like another implicit layout, and hence very similar. Didn't the crowdsourcing paper find that more rectangular and less square aspect ratios work better for interpreting tree maps? I don't actually recall that. If it did, then I'm sure like there must be some limit, right? Because in the example here, you can see some cases, let's say down here, where you have these super long rectangles and you can barely see it anymore. So in this case, I'm like very confident that this is not better than the chart on the right. But there might be some kind of like trade-off, but I don't actually recall the details from that paper. Okay. So the Sunburst idea is very similar to the tree map, so that we have implicit, that we have edges encoded implicitly, but it is better at showing kind of the tree structure. So here, this is kind of our root node. So if we have a tree, this would be a root node. And then we have like its leaves, its immediate leaves here, here, and so on. And so there we would have like our leaves, and they are kind of like encoded in this gray, blue, and orange space here. And then this gray like segment here has a lot of subfolders on its own. And so you can then the subfolders are visualized here as circle segments and so on, like recursively down until we are arriving at leaves. So that's kind of like a very neat encoding. It's kind of a little bit it focuses a little bit more on the tree topology as opposed to the to just the attribute or to just the nodes, and especially the node attributes. And that can be sometimes very useful. So, and then here is kind of like an interactive demo that like a student of mine built a couple of years ago, where you kind of like can navigate, because these trees can get very deep. You kind of can navigate them dynamically. And so here, like you see that there's like the overview is in the middle, and then you can click any of the segments. And that these segments, they pop out and expand around the circle. And so now you're looking at just like this one subfolder. And eventually you can kind of like go down all the way until where you have like files in a hierarchy. Any questions about sunbursts? Okay. So, and then the final technique is kind of like, if you think about a sunburst that kind of uses this radial layout, if you just unfold that radial layout, you get into this like linear layout of an icicle plot. And so this is exactly the same idea. You have like a root node here at the top, and then here you have your sub nodes at the first level, and so on and down the line. And so that can be like useful and efficient. It looks maybe a little bit less interesting, and it's maybe a little bit less efficient because than the tree map, but it is still like an easy to implement, easy to do, and easy to understand visualization. And here's like a zoomable version of that, where I can kind of like click individual items and zoom down, and this is all done with D3. So what do you think? The differences, pros, cons, which ones do you like the most? Have you ever used any of them? Any thoughts? No comments? Anybody?
I like the rectangle one because the last one, I mean, because it's more readable and easy to get everything, I think.
So you mean the icicle plot or the tree map? The one in the center or on the right?
On the center.
On the center. Yeah. It's kind of like easy to read. It has the whole tree structure. I guess it might be a little bit, let's say it's maybe a little bit less scalable than the tree map itself. I see some comments here. I see an issue with the tree map tracking relationship and higher. Yes, definitely. Whenever you need to look at topology, the tree map is the wrong thing, right? The tree map gives you a little bit of structure by how it kind of nests things in rectangles. So you kind of, by looking at this tree map here, you can kind of guess that this here is one big subfolder. And then here we have one big subfolder. But it's kind of hard to make out, right? You kind of have to look at the at kind of like where does a rectangle emerge, and that can be tricky. So it's not all that easy to see. I see some other votes for the icicle plots.
One of my favorite visualizations is taxonomy visualizations. I think the radial sunflower plot works well for this because they often aren't very deep, but you can get a good idea of what is in the field in terms of a taxonomy with these visualizations fairly well.
Yeah, so if you have kind of something where you want to like focus on the root and kind of like how, like roughly how is like a very deep tree composed, something like Sunburst is very nice, especially if you have these kinds of navigation features. Okay, great. So that kind of brings us to like a wrap up for implicit representations. If you think about this, they're very space efficient, especially tree maps, because they don't explicitly draw edges. And so especially the tree maps scale very well up to very large graphs. There's like actually a paper about visualizing 1 million nodes in a tree map. In most cases, they're well suited for attribute-based tasks on the nodes, although that really is only true for the leaves, right? Like basically, we're only showing attributes of the leaves. In case of file sizes, it's kind of convenient because the size of a folder is the sum of its children. So in that case, we do show kind of also the size of the folder. But if you had anything else on the kind of like intermediate nodes, it would be tricky to visualize or impossible to visualize. Depending on the spatial encoding that you use, they can be useful for topology-based tasks, icicle plots, and Sunburst plots definitely are pretty okay for topology-based plots, topology-based tasks. And the negatives is these implicit representations, they can only represent trees just because of this arrangement of adjacency or containment that encodes the edges. That doesn't work if I have like more than one relationship in general. And because we are using the node positions to represent edges, we cannot freely arrange them. So we couldn't combine like a map with a tree map, for example. And it is kind of like useless to pursue any tasks on the edges in these kinds of representations. So I want to kind of point to this tool here. This is kind of like a collection of every tree visualization technique ever published, including like a little screenshot and the classification. And so they're looking at dimensionality here. Is it 2D, 3D, or hybrid? Is it node link, implicit, or hybrid? Is it orthogonal or radial or some other alignment layout? And so you can browse through that. It's treevist.net. I'm not going to go there now, but it is a cool tool. Okay, so to wrap up the network lecture, I just want to point to a couple of tools. Like if you ever have to visualize a network, of course you can do it in D3, but sometimes you just want something that is easier to do. And so Gephi is one tool for network visualization that I can definitely recommend. They're probably the best layout algorithms out there in Gephi. Cytoscape is a very popular tool for biology applications. So there's like hundreds and hundreds of plugins that are specific to some biology use cases, but it's also a super useful general purpose network visualization tool. And it also, you can export to a web. It's kind of like a desktop application, but you can kind of create web representations from it with Cytoscape Web here. Okay, and then finally, if you want to do some kind of very basic network visualization, but mostly looking at kind of like some network analysis, Python libraries such as NetworkX are useful. Great, so that wraps up networks. Any questions about networks while I'm switching my slide deck here? Okay, so in this part of the lecture, I want to talk about storytelling. And this is kind of also, this lecture is based, like a significant chunk of this lecture is based on this paper by Jeff Hare and Siegel, who kind of characterized the design space of storytelling and visualization. The paper is from 2010 and actually got like a Test of Time award this year at the VIS conference. And so this is one of those papers that all the grad students should be reading because it's kind of like within the scope of the stuff that I might be asking on the exam. So the link, I'll mention it again later. The link is also on the website on the schedule. But what do I mean about storytelling? Like we kind of like hinted a little bit at this already in various kind of like homeworks, and I talked about this before. But now we want to look a little bit more systematically on storytelling. And I first want to play this like fairly long, but still pretty interesting video, and then want to have a bit of a discussion about it.
I saw recently that I can't get out of my head. A Harvard business professor and economist asked more than 5,000 Americans how they thought wealth was distributed in the United States. This is what they said they thought it was. Dividing the country into 5 rough groups of the top, bottom, and middle 3 20% groups, they asked people how they thought the wealth in this country was divided. Then he asked them what they thought was the ideal distribution. And 92%, that's at least 9 out of 10 of them, said it should be more like this. In other words, more equitable than they think it is. Now that fact is telling, admittedly, the notion that most Americans know that the system is already skewed unfairly. But what's most interesting to me is the reality compared to our perception. The ideal is as far removed from our perception of reality as the actual distribution is from what we think exists in this country. So ignore the ideal for a moment. Here's what we think it is again. And here is the actual distribution, shockingly skewed. Not only do the bottom 20% and the next 20%, the bottom 40% of Americans barely have any of the wealth. I mean, it's hard to even see them on the chart, but the top 1% has more of the country's wealth than 9 out of 10 Americans believe the entire top 20% should have. Mind-blowing. But let's look at it another way, because I find this chart kind of difficult to wrap my head around. Instead, let's reduce the 311 million Americans to just a representative 100 people. Make it simple. Here they are: teachers, coaches, firefighters, construction workers, engineers, doctors, lawyers, some investment bankers, a CEO, maybe a celebrity or two. Now let's line them up according to their wealth. Poorest people on the left, wealthiest on the right, just a steady row of folks based on their net worth. We'll color code them like we did before based on which 20% quintile they fall into. Now let's reduce the total wealth of the United States, which was roughly $54 trillion in 2009, to this symbolic pile of cash. And let's distribute it among our 100 Americans. Well, here's socialism, all the wealth of the country distributed equally. We all know that won't work. We need to encourage people to work and work hard to achieve that good old American dream and keep our country moving forward. So here's that ideal we asked everyone about, something like this curve. This isn't too bad. We've got some incentive, as the wealthiest folks are now about 10 to 20 times better off than the poorest Americans. But hey, even the poor folks aren't actually poor, since the poverty line has stayed almost entirely off the chart. We have a super healthy middle class with a smooth transition into wealth. And yes, Republicans and Democrats alike chose this curve. 9 out of 10 people, 92%, said this was a nice, ideal distribution of America's wealth. But let's move on. This is what people think America's wealth distribution actually looks like. Not as equitable, clearly, but for me, even this still looks pretty great. Yes, the poorest 20 to 30% are starting to suffer quite a lot compared to the ideal, and the middle class is certainly struggling more than they were, while the rich and wealthy are making roughly 100 times that of the poorest Americans and about 10 times that of the still healthy middle class. Sadly, this isn't even close to the reality. Here is the actual distribution of wealth in America. The poorest Americans don't even register. They're down to pocket change, and the middle class is barely distinguishable from the poor. In fact, even the rich between the top 10 and 20 percentile are worse off. Only the top 10% are better off. And how much better off? So much better off that the top 2 to 5% are actually off the chart at this scale. And the top 1%, this guy, well, his stack of money stretches 10 times higher than we can show. Here's his stack of cash, restacked, all by itself. This is the top 1% we've been hearing so much about. So much green in his pockets that I have to give him a whole new column of his own because he won't fit on my chart. 1% of America has 40% of all the nation's wealth. The bottom 80%, 8 out of every 10 people, or 80 out of these 100, only has 7% between them. And this has only gotten worse in the last 20 to 30 years. While the richest 1% take home almost a quarter of the national income today, in 1976, they took home only 9%, meaning their share of income has nearly tripled in the last 30 years. The top 1% own half the country's stocks, bonds, and mutual funds. The bottom 50% of Americans own only 0.5% of these investments, which means they aren't investing. They're just scraping by. I'm sure many of these wealthy people have worked very hard for their money, but do you really believe that the CEO is working 380 times harder than his average employee? Not his lowest paid employee, not the janitor, but the average earner in his company. The average worker more than a month to earn what the CEO makes in 1 hour. We certainly don't have to go all the way to socialism to find something that is fair for hardworking Americans. We don't even have to achieve what most of us consider might be ideal. All we need to do is wake up and realize that the reality in this country is not at all what we think it is.
Okay, so here's the link. So this was kind of like video-based storytelling. What do you think? I don't want to talk too much about the politics of that, but like first, the visualization. Was it kind of like well done? Was it kind of like biased, unbiased? How was it dramatized? What do you think about the visual encodings? Any thoughts?
I liked the visual encoding. I thought it was effective at getting the point across.
So Marcus is saying that you could also watch it in mute and get the main point. Yeah, so there's clearly a layering, right? So it contains all of the information, but still has narration on top of it. So that's always very useful if you do a story like this. Excellent use of color for encoding the class distribution, while size positions are effectively used to show the wealth distribution. Yeah. One storytelling device that they used here, which we'll talk about a little bit later, which I find super intriguing, is asking people about what they think. And by kind of like asking what you think and then kind of later showing what reality is, it kind of like makes us engage with the problem a little bit more. And so in this case, they asked just like a random sample, but I'll show you later some techniques how you can do that in like an interactive news story where you can ask people like, what do you think happened here with this data set, and then show them later, which is kind of like a wonderful way of engaging people. Yeah, Vai is saying that he felt the Amios music was tilting and didn't feel objective or scientific. Yeah, I don't think that this was meant to be objective or scientific, right? They clearly have an agenda here with this video. It was also kind of like the intonation of some of the words, like dreaded socialism, right? That was clearly like revealing that this wasn't meant to be an unbiased presentation of the facts, but had a political agenda. So definitely, I agree. Any thoughts? Okay, so well, I'm also happy to have a discussion if anybody wants to later on this visualization in the chat. Sorry,
I saw recently.
So let's talk about this a little bit more and kind of like how do you do actual storytelling? So a good story is not just about providing facts and data, right? It is they situate and give context, they engage, they educate. And so the typical questions that you have in journalism and in storytelling are like who, what, where, when, why, how. And so you can also think of this as kind of like every story has the three phases, like the beginning, the middle, the end. And in the story that we just saw, we can kind of like easily identify these different phases. Like we have the introduction, we kind of see the problem. The climax is when we see the actual wealth distribution. Then we have a resolution and conclusion. And so that's kind of like a useful way to think about whenever you kind of like create a data story or write any other kind of story. And data visualization it's quite useful for storytelling. Just like an interesting fact is that I think 5 most visited pages or articles on the New York Times are all interactive data stories. And so they are kind of like super popular. It's kind of like a trend in kind of journalism to have these interactive data stories. And as you can see, there's plenty of them since I'm mostly relying on these kinds of newspaper visualizations to teach in this course. But really what they're about is underscoring your arguments with data and facts. You want to leverage the power of visualization to show trends, to show correlations, to show outliers, and to convey magnitudes. And so here's another video. I'm going to like show this like a much shorter snippet of that. You might have heard about it. This is like Al Gore's An Inconvenient Truth about climate change. And I just like the storytelling device that he employs here, and I want to show that.
Compared to what's going on now, there's just no comparison. So if you look at 1,000 years worth of temperature and compare it to 1,000 years of CO2, you can see how closely they fit together. Now, 1,000 years of CO2 in the mountain glaciers, that's one thing. But in Antarctica, they can go back 650,000 years. This is the first time anybody outside of a small group of scientists has seen this image. This is the present day era, and that's the last ice age. Then it goes up. We're going back in time now, 650,000 years. That's the period of warming between the last two ice ages. That's the second and third ice age back, fourth, fifth, sixth, and seventh ice age back. Now, an important point. In all of this time, 650,000 years, the CO2 level has never gone above 300 parts per million. Now, as I said, they can also measure temperature. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, well, let me put it this way. If my classmate from the 6th grade that talked about Africa and South America were here, he would say, do they ever fit together? Most ridiculous thing I've ever heard. But they did, of course. And the relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer because it traps more heat from the sun inside. In the parts of the United States that contain the modern cities of Cleveland, Detroit, New York, in the northern tier, this is the difference between a nice day and having a mile of ice over your head. Keep that in mind when you look at this fact. Carbon dioxide, having never gone above 300 parts per million, here is where CO2 is now. Above where it's ever been as far back as this record will measure. Now, if you'll bear with me, I want to really emphasize this point. The crew here has tried to teach me how to use this contraption here. So if I don't kill myself, I'll. It's already right here. Look how far above the natural cycle this is, and we've done that. But ladies and gentlemen, in the next 50 years, really in less than 50 years, it's going to continue to go up. When some of these children who are here are my age, here's what it's going to be in less than 50 years. You've heard of off the charts. Within less than 50 years, it'll be here. There's not a single fact or date or number that's been used to make this up that's in any controversy. The so-called skeptics look at this and they say, so that seems perfectly okay. Well, again, if on the temperature side, if this much on the cold side is a mile of ice over our heads, what would that much on the warm side be? Ultimately,
okay, I think you got the point. I think he makes use of like a very effective storytelling device here, right? He does this kind of like letting people match data between two time series, discussing this in detail, and then showing some kind of like the most like dramatic piece of it later. And he does this very like underscores it with the use of this contraption, as he calls it, to actually have to like climb all the way up there to be able to point at these data points. So let's take apart like one of like a typical data story in kind of like a magazine style. So we have these kind of like phases of storytelling, and you can kind of refine this a little bit in an interactive data story or in a magazine data story. Here, this is kind of like a visualization that is meant to show about like whether baseball players were taking steroids based on looking at their records of how many home runs they hit. And so we have kind of like the introduction here. We have like a big number and then the title. So that gives us a little bit of, like, we immediately get what's going on. Then we have some context, and legend. So like, who are the players that we're looking at here over time? Then we have the main story. So we can see that kind of like Babe Ruth had a fairly like stable trajectory, and then Barry Bonds, who is kind of like the person in question here, is suddenly has this inflection point somewhere in the middle, and rapidly increases the like his record of home runs. We have kind of like an annotation of a key point. We can see that here is something that is noteworthy to the reader. So there's like, in this 14th season, he began taking steroids, and then you can see his record taking off. And then you get like more context using matching on content by using color and trends to kind of like pull outs for this, to compare this to like this baseline very clearly, and give some more additional contextual information. And then, of course, this is like a big subject. We can look at many different players like this, right? And so we can look at other players, or we can look at different paths here. And so here they've used a bar chart, because the bar chart is probably more efficient to show these kinds of like steep changes. Like Barry Bonds, you see that like in the line chart, like the steep inflection here isn't quite as dramatic as it appears here, right? So this here is kind of like a much more like, it emphasizes a change much more compared to overall trends. Okay, so and this now goes back to this paper that I mentioned earlier by Siegel and Hare. And there's a couple of different types that we can classify of data stories. Like, there's these 7 genres. There's like a magazine style data story, which we've just seen, an annotated chart, a partitioned poster, or this could actually be more what we just saw, a flow chart, a comic strip, a slideshow, or like a film video animation, of which we saw 2 examples in the beginning. And so they are like very different in terms of like, the main difference is similar to interaction, right? Is it author or reader driven? And author driven are those where it kind of like, the person that creates the story gives you like a linear order and has some heavy messaging. So you have kind of like, a video is clearly the most author driven and the most linear, because you can't really skip ahead easily or like navigate this more arbitrarily. And typically these like author-driven stories have no or very limited interactivity. And on the other hand, on the other side, you have these reader-driven stories where you have kind of like no ordering at all, and no messaging, but completely free interactivity. And this is also for news. This isn't all that common, but I'll show you a couple of examples. And so a lot of news is somewhere like in the middle, maybe a little bit on the author-driven side. And then they have these kind of like more specific examples of like a Martini glass structure, which is kind of like a very compelling approach. So you start with an author-driven visualization, and then you open it up for exploration. And so here's like an example of this this Martini glass structure. This is about U.S. gun death in 2013. This is by Periscope, for like a data visualization firm. And so right now we're in the author-driven format. This is kind of like almost like a video. It's completely interactive. So here we're like seeing how long did certain people live. This is kind of the colored line, and how long should they have lived if they were not victims of gun violence or gun death. And so like also, of course, going for a dramatic effect here, visualizing it, and we're still in kind of this completely author-driven mode. And then eventually this wraps up. And now you can start to interact with it. So you can kind of like start asking questions, like first drill down. Who are those people? This is real data. So you can kind of like look at who are these exact people. Or you could kind of like look at any differences. So maybe how does this look for if we only include females? Or like compared to all other victims, or if we look at adults over 30, like females, adults over 30, and so on. So now we can kind of like drill in and kind of like reveal the rest of the story on our own. An interactive slideshow, in contrast, is kind of like split into multiple scenes and allows interaction midway. So you could think of this, the yield curve, the 3D yield curve we had with the New York Times as one of those. So we kind of like had this stepper. It's split into the scenes that have some kind of like emphasis and annotations, but you can still play around with it and dynamically like manipulate the scene. And then a drill down story is kind of like letting the reader completely decide which path to follow, but all paths are annotated. So this needs Flash, so I'm gonna not, well, this is gonna take a minute for me to enable Flash, so I'm gonna skip over this, but I guess you can imagine it. Great, so let's talk about a couple of strategies for storytelling. So we, like one thing that is super important is like always have descriptive titles, descriptive subtitles, using annotation and then using highlights, for example, through saturation. So like I'm just going to show you a couple of examples of basically the same data, the same visualization, just like with neutral or non-storytelling presentation on the one side and storytelling presentation on the right. So like here you have ice cream flavor preferences based on 2014 survey of elementary school students. You can see kids like chocolate ice cream. But if you want to tell, like if you want to make this a data-driven story, you could just kind of emphasize the key point already in your title. Chocolate was most popular flavor among elementary students surveyed. And then emphasize that particular point. So same data, both are very accurate representations. It's just like the one really takes care of like what is the key takeaway and presents it convincingly. The other one is just like a data presentation. Here we have like project results before and after implementation of grant on the left, and then on the right we have project A had the greatest gains after the 4-year grant funding. Again, using kind of like contrast and like reframing of the title to drive home the key point that you can read from the chart. A descriptive title, a descriptive subtitle, and annotation, like as I said, are super. Like here's another example for that. You have like a number of studies funded each year on the left, or on the right. We're funding more studies each year. Beginning in 2013, we set aside new funding to measure the effectiveness of our initiative, and we evaluated 39 out of our programs in 2015 alone. So yeah, like clearly those are like same data, but just different framing, and one is much more engaging than the other because of that. Okay, so my voice is kind of giving out a little bit today. In terms of interactivity, we have like we talked a little bit about this when we talked about interaction. We have like steppers, we have scrollytelling with scrolling, we have like play forward, rewind, and so on. We have details on demand. Like this is the details on demand was like a good example of like in the OECD visualization that we had on the exam. You had like these details on demand. You could kind of like select your state and get details about that. And then this one very important strategy is making it relevant to the reader. Like, what do you think? Who are you? Where do you live? And it always is much more interesting to a reader if you can make something relevant to the reader. And so like the New York Times has been doing a good job at this kind of stuff. I can actually just let the New York Times allow to know my location. And this is a visualization about climate. How much warmer was your city in 2015? And now they're supposed to be switching to Salt Lake City. Yeah. And the cool thing here is that this is kind of like an interactive data story that works for any city, right? This isn't something where somebody has gone in and created these annotations individually for every single city, but this is kind of like just in the data. So these annotations, like this is a record high, this is a record high. Here we have tied the record. we didn't have actually like a record low in 2015 in Salt Lake City at all, right? So that's kind of interesting. But I can do that for, let's say San Francisco. So that works for any kind of place in the US. And so that's kind of like a very cool way of make it matter to your audience if you have like a very, let's say, distributed audience. And this is this piece about asking for opinions or asking about prior knowledge that I mentioned earlier. So first you ask a reader to draw a trend and then juxtapose it with reality of what other people think. And so there's two examples here. I'm going to show this one. And this is about like what got better and worse during Obama's presidency. Under President Obama, the unemployment rate, and now I'm supposed to be drawing it here. And so like we know that there was a financial crisis, but and so maybe this is what happened. So the unemployment rate went high. So now I've drawn this, and now I can actually click and show me how I did. And well, I kind of underestimated how bad it got quickly after he took presidency, but then I also didn't quite show the downward trend that we have here. And so there's like others here. So the number of immigrants convicted of crimes who were deported, like you would kind of like guess that, well, this was a Democratic president, so probably this went down. You could say, show me how I did. And you see that doesn't completely align with my preconceived ideas. Like my version of reality is not kind of reflected in the fact here. Of course, I've looked at this before, so this is all a little bit fake for me. But if you want to play with the rest of this here, here's the link, and see how many of those kind of like you roughly get right, and whether there are some ones that are surprising to you. But I think that this kind of like idea is like for data that people have like a general sense about, but don't necessarily know all the facts, is like super engaging. That can really draw people in and make them think about each of these particular, let's say, phenomena or data sets out there. Okay, and then of course this all goes back to visualization design. Like we have like the framing is important, the titles are important, like highlighting in like inflection points and so on is important, but also just pure visualization design matters. And so here's a visualization about death on US roads. What we have here on the left is kind of like different years and what is the death rate over the seasons in each of these years. And the years are shown with like very colorful lines. And then we have like a heat map that shows us the calendar for one particular year or for an average year. And then on the right, we can see like these holidays over time. Like we can see slightly here in the middle, we can see that holidays like around 4th of July, New Year's, and around Christmas are pretty bad for car fatalities. And so we have like a detailed view here on the right that shows that this is still a problem, but it's gone down, so it's getting better. So what do you think about this visualization?
I find that the chart on the left is, I think it's too busy to really take away anything from.
Yeah, exactly. We have this chart on the left, and the colors are not actually meaningful, right? They are, they're almost like what do they mean, right? I don't know whether a gray color is a recent year or a red color is a recent year. I see that it's hard to draw the connection between holidays and death. Yeah, it's kind of like not very kind of clear that this is like the effect that that we're supposed to be looking at here. So it's not very pronounced, and kind of like the relationship isn't super clear. Why is August higher than some other months? I see. I'm guessing, this is just my interpretation, August is like a time when people go on road trips and travel.
The fact that they're using a straight line for the holidays getting safer makes me think that they're just doing linear regression, which can be dangerous for data analysis. Like, it'd be interesting to show the scatter plot behind it as well.
I agree, but the blue line looks like it has a bit of a knee in here. So maybe it's not a completely straight line, but it's hard to tell. So there's somebody, one thing that I think is interesting is how normalizing to the US population would affect this. Well, we're not comparing between different countries or states, but if we did, that would be super useful, yes. Okay, let's look at the redesign of this. And it kind of keeps the main design decisions the same, but it just changes a couple of more subtle things. So here's a redesign. Like we want viewer colors, we want to have some averages for context, we want better scales, and we want richer annotations. And so here's the same chart, same information, same basic visual encodings, but with like appropriate storytelling. So first, the title is almost, well, the title is the same. We just have like better like layout, better arrangement. So like left aligned looks better. But then we have kind of like, we can see like that here we have only a single color. Then we added this average for all of the years. And then we have annotations that pull out some specific years. So there's like 1980, and then we have like 2009, which is much more recent. And so we can kind of like from this, we can already speculate that things have gotten better over time. And then here in this heat map, they have kind of like created this, diverging color scale where kind of like your average number of fatalities, like also notice that here they started at 810 and went all the way up to 5,000. They now go to start from 2,500, which is kind of like the seems to be the lower bound in this data set, and goes to 5,000. And so and then we have this like in the middle here, we are changing from gray to red color scale, which of course emphasizes the outliers much more. And so here I can very clearly see that like the holidays in January and at the end of December on Christmas is like a very lethal time of the year. And then we have the holidays here in July and August and September, where people travel like probably a lot of miles, and therefore these fatalities rise. And then we have like instead of like, I don't know, maybe it was a line chart, but now it's explicitly, maybe it was straight lines, but now it's explicitly a bump chart, right? So it compares a specific year, 1975 to 2011, and leaves out all of the intermediate context very consciously. So yeah, I think probably this was also meant to be a bump chart up here. Here it's kind of clear what is meant. And then here, kind of like the axes were rescaled to emphasize like not the 0 point, but the data. So very much like what we've talked about when we talked about designing. Okay, so any comments about this? Great. So now let's talk a little bit about engagement. And in any story, you need to think a little about like, who is your audience? Are you giving like a presentation or creating a data story for a specific group of people, or is it like a very general population, or is it like all academics? And so that's just like always very useful to think about who's your audience. What do they know? What motivates them? What experiences do you share? What are your common goals? What insights can you give them? What do you think that they don't have? And so this is kind of like, depending on your target audience, you might want to vary between like a neutral presentation, an opinionated presentation, a low information density, and a high information density presentation. And so we have these kind of like different segments based on your audience. Like you want some like the gist in a very neutral way. For example, in a board meeting, you want to have some high information density in a neutral way in like a research group or like a work group meeting. You might want to have like an expert panel. Typically tends to be opinionated because that is kind of like engaging. And then you have something like TED Talks, public media that tend to be opinionated, but also have fairly low information density. And somewhere in the middle here, we have teaching, so kind of like a compromise between opinionated and and neutral and high information density and low information density. And of course, these are just like rough outlines, right, to get you thinking about it. This doesn't mean that these are like exactly like a board meeting fits in here. This is not a data visualization, but more of like a business school kind of graphic here. And so if you look at this particular like very dated visualization of market share of these like smartphone platforms, is this low or high information density? Is it neutral or opinionated? So I would say this is very low information density, but it's also pretty neutral. If we look at this, this is like a sales dashboard, which is fairly high information density, but I would presume it is pretty neutral. So it's kind of like clearly a different type of visualization. If we look at this, where there's smoke, there's cancer, we have kind of like some like information in here. It's not super high in information content, and it doesn't seem to be opinionated, right? It seems to be like a fairly factual representation of data. And then finally, we have this chart here. Is this Iraq's bloody toll? Is this neutral or opinionated? Well, very clearly, this is very opinionated, right? You kind of like, there is a very strong kind of like effect that by making this bar chart look like blood, right, running blood. And so it's also like slightly biased in terms of like the how the title is phrased. Like there here is kind of like an alternative representation, like just flipping this chart around and changing the title. It's kind of like, you could also say Iraq death on decline, right? So here we clearly had somebody had an agenda, and so it's very opinionated. And so if we have like, if you look at this, we have like high information density, low information density, neutral, and opinionated. We could kind of like put those here, and then we can say like this is roughly these different target audiences that you could think about. Okay, great. So based on this, I want to do an exercise, and this exercise will be kind of like the wrap up of today's lecture. You can kind of submit this exercise as an assignment. If you, as an activity, if you haven't filled up your slots already. And I want you to kind of like go through these 3 data stories here and analyze them. And I'll have a handout here, like thinking about it in like, what is the genre? Is it like a magazine, annotated chart, petition poster, flowchart, comic strip, slideshow, video, or animation? Is it author or reader driven? Can you make out a particular structure, such as Martini glass or interactive slideshow, a drill down story? Does it have a good introduction? What is the medium used for the introduction? Is it opinionated or neutral? Does it use titles, legends, and highlights well? Does it use interactivity well? And is the visualization well designed? And so we'll do this for these 3 different visualizations. And I'll start breakout rooms. And let me just, as usual, has already put the link to the activity in the chat. And so just visit that link. And this is also kind of like the end of today's lecture. So when you're done, where you can just wrap it up and then submit your like notes about this to the activity.
So is this different from the bonus on Canvas?
What's that?
Is this the same as the bonus on Canvas?
No,
or...
the bonus is for the in the sets lecture. Well, this is just an activity. Any other questions before I start the breakout rooms? Okay. Good. Thanks, everyone.
Alex, you said the bonus was in the sets lecture?
Yes.
What day was that on?
I don't know exactly how it's coming up. I think after that.
You kind of broke out there. I'm sorry, I missed that.
I don't know from the top of my head, but it's either next week or the week after that.
Oh, okay. I thought I missed it. All right. Thanks.
Yep.